Hey guys, so here's the review question I was talking about in class today. What's the difference between a factor and a multiple? Explain it to me like I'm a fifth grader and have never heard either term before. Your answer should be at least 3 to 4 sentences long. It can be longer. It doesn't need to be shorter than that though. And like I said, from each class, the person with the best response will receive 5 bonus points on the next test. So you should get a pop-up box now. Okay. So a prime number, and we're going to start talking about prime factoring, but first we need to have a discussion about prime numbers. A prime number is a number that its only factors are 1 in itself. So as you can see, I have 4 numbers down here. So we're going to start with 3. 3, we'll list the factors of 3. They are 1 and 3. So that fits the definition. A prime number is a number that's only its factors are 1 in itself. So 3 is prime. Okay. If we list the factors of 4, we have 1, 2, and 4. Well, this has more factors than just 1 in itself, so we actually call those numbers composite. Okay, so if we take a look at 11, the factors of 11 are 1 and 11. All right, well, that's it. Those are the only 2 factors of 11, so it is prime. Okay, so if we take a look at number 9, the factors of 9 are 1, 3, and 9. Well, since it has more than just the factors of 1 in itself, we would then say that 9 is composite. We're not too concerned with composite numbers. We're more concerned with prime numbers. Okay, so we're going to start dealing with prime factoring now. When we're prime factoring, I have a technique that I like to use. You may have learned how to do prime factoring using the tree method. I like to use something that I call the stack method. The first thing we need to discuss are the 5 most important numbers when dealing with prime factoring, and those are 2, 3, 5, 7, and 11. These are the first 5 prime numbers. So let's see how we would use those to find the prime factors of 64. So it's a step-by-step process. The first thing we do is we look at 64 and we ask ourselves, is 64 divisible by 2? And of course it is. So we'll do 2 goes into 64 32 times. So then we'll do it again. Does 2 go into 32? And yes, it does. So 2 goes into 32 16 times. Okay, does 2 go into 16? Yes, it does. 2 goes into 16 8 times. Okay, does 2 go into 8? Yes, it does. 4 times. And does 2 go into 4? Yes, it does. I'm going to squeeze it at the top 2 times. Okay, whenever you get a prime number on the top, you can stop. So the prime factors of 64 are 2 times 2 times 2 times 2 times 2 times 2. Or we could just say 2 to the 6th power. Okay, so those are the prime factors of 64. Let's take a look at another example. I'm going to write my 5 important numbers over again at the top. 2, 5, 7, and 11. These are the 5 numbers that you need to use most of the time. Sometimes you need to use bigger prime numbers, but generally these are the 5 numbers that we will be using. So let us find the prime factors of 48. We'll start with 2. Does 2 go into 48? Yes, it does. 24 times. Okay, does 2 go into 24? Well, yes, it does. 12 times. Does 2 go into 12? Well, yes, it does. 6 times. Does 2 go into 6? Yep, 3 times. 3 is a prime number, so the prime factors of 48 are 2 times 2 times 2 times 3, and then we can rewrite that as 2 to the 4th power times 3. Okay, let's take a look at another example. I'll write my numbers at the top again. Okay, so let's write out the prime factors of 100. Does 2 go into 100? Yes, it does, 50 times. Does 2 go into 50? Yes, it does. 25 times. Does 2 go into 25? Nope. Does 3 go into 25? Nope. Does 5 go into 25? Yes, it does. 5 times. We have a prime number at the top, so we can stop. The prime factors of 100 are 2 times 2 times 5 times 5, or 2 squared times 5 squared. Okay, so let's take a look at another example. Let's find the prime factors of 33. I'll write my numbers at the top again because they're good for guidance. Okay, does 2 go into 33? No. Does 3? Yes. How many times? 11. Look, we have a prime number at the top, so the prime factors of 33 are 3 times 11. That one was a pretty easy one. Let's take a look at one more. Let's find the prime factors of 165. Okay, this is a much bigger number than the other one. So let's see if our trick will hold true for this one. Okay, so how many, does 2 go into 165? Nope, it does not. Does 3 go into 165? Well, if we remember the divisibility rules of 3, it sure does. So 3 goes into 165 55 times. Okay, does 2 go into 55? Nope. Does 3 go into 55? Nope. Does 5? Yes, it does. 11 times. Well, we have a prime number, so we could stop. So the prime factors of 165 are 3 times 5 times 11. All right. Try these now. Okay. What are the prime factors of 27? What are the prime factors of 100? What are the prime factors of 36? Okay? You should be getting a pop-up box for these now. Okay, so the prime factors of 27, well, 2 doesn't go into 27, but 3 does, 9 times, and 3 goes into 9 3 times. So the prime factors of 27 are 3 times 3 times 3, or we could just say 3 to the third power. Okay? Okay, and I know I gave you 100 as an example, but let's try it again. Hopefully you did it correctly on your own. So 100, well, 2 goes into 100 50 times. 2 goes into 50 25 times. And 5 goes into 25 5 times. Sorry about squeezing that in. Which means the prime factors are 2 times 2 times 5 times 5. Or 2 squared times 5 squared. Okay, let's do 36 now. 2 goes into 36 18 times. 2 goes into 18 9 times. And 2 doesn't go into 9, but 3 does 3 times. So the prime factors of 36 are 2 times 2 times 3 times 3, or 2 squared times 3 squared. Okay? Don't forget we are going to have a 5-minute quiz on that order of operations open-ended question that I told you guys about today. So make sure you look over order of operations. If you need to watch the video again, go for it. And that's about it. Have a good night.